Hello everyone. In this short video, I just want to touch base with you guys regarding um, simple hydraulic circuits that can do a certain thing, which you can quickly draw freehand if need be. So, for example, I have two sample circuits here today. In the first one, the question may look like this. Draw a hydraulic circuit of a forging machine using the following components. So these are all the conditions that you're going to have to fulfill in order to finish the circuit. Consider them as conditions that must be fulfilled. A single acting cylinder. So you're going to be using a forging cylinder that is single acted. So that must have a spring for the retraction motion. A 3x2 push button that forges when pushed. So this is talking about the DCV, which must be a 3x2 DCV because it's a single acting cylinder. It only requires a 3x2 DCV. Number 3, use a hydropneumatic accumulator to prevent the DCV from hydraulic shock. So that's something we have to do whether or not we're asked to, because every circuit that has a direction control valve needs a shock absorbing dampener beside it to prevent the delicate internal parts from being damaged due to hydraulic shocks. Number 4, a check valve should be used to prevent backflow to the pump. As soon as you have an accumulator, you must have a check valve to prevent this kind of backflow towards the pump from the accumulator. Number 5 and final one is a hydraulic power unit, which is basically a tank, a filter, pump, a motor, pressure relief valve, and so on to power this circuit. So I'll begin with drawing the pump. Okay, so here's my pump. It has a triangle at the end. The triangle must be solidified with black, because otherwise, if you leave it hollow, that means it's a pneumatic compressor, not a pump. It needs a motor, so I'll draw a shaft and then a motor. And then I need a filter. Here's my quick filter, and everything begins from the tank. After that, I have to draw a line because the HPU is not yet finished unless you draw the pressure relief valve. So that's what I'm going to draw now. Normally closed. That's why the spool must be drawn offline. And then I need a spring, which is variable. And then the rest goes to the other output goes to the tank. You can draw it like that. So that's my HPU. So you may want to stop here and put it in a box to nicely package these components as the HPU. Labeling is going to be the last thing you want to do. You don't want to spend time labeling before you finish the circuit, because that's most important. A single acting cylinder we needed, so we'll have to draw a single acting cylinder, and we have to draw a DCV. If you're using pencil, it's really easy. The DCV is 3x2, so we have to draw 2 blocks for 2 positions of the DCV. Here are my 2 blocks. So that's a 3x2. So the position 2 is ensured by 2 blocks. Now 3x2 means it has 3 ports. One must be dedicated for the pump, one for the tank, and one for the cylinder, because it's a single acting cylinder. So let's now draw the single acting cylinder. I'll draw a very slim cylinder that has only 1 port. Here's my piston, and then there's a spring. And this is a 3x2 push button. So there must be a push button on this side. For this push button to retract, we need a spring. And it forges when pushed. Forges mean it extends the cylinder for forging when it's pushed. So the pushing sequence should be here. The flow sequence should be here. And the non-flow sequence should be here. The pump here is isolated. Only when you push it, the pump is going to be here, sending the fluid to the single acting cylinder. Otherwise, the single acting cylinder should be releasing the fluid back. Now you can have your tank here. And then a hydropneumatic accumulator. So to protect this DCV, we need a hydropneumatic accumulator. That's what I'm going to draw now. Pay attention to the detail of the type of the accumulator. Do not have to draw whatever connections you want to use here. You can just connect it by one single line. That should be it. And then we need, if you're using pencil, this is the best thing for drawing circuits, because sometimes you will have to erase to make amends. So that's your check valve to prevent the pump from backflow from the accumulator. So now pretty much the circuit is done. What is left for you to do is label the component. So this one is the single acting cylinder. This one I'll preferably use a different color. This is the hydropneumatic accumulator. This one is the check valve. I'm using abbreviations. Do not use the abbreviations when you're doing this circuit. 3x2 push button. And that's the pressure relief valve. You don't have to really detail everything out here, but since you have labeled the whole thing as HPU to save time, you can just leave it like that, and that should be it. And this is a push button operated 3x2 DCV. So that the turning points in this circuit that will be checked for are the single acting cylinder, the push button, whether or not you have fulfilled all these conditions. And HPU pretty much basic to all the different kind of circuits. Next, I want to show you another circuit here. Draw a hydraulic circuit to extend and retract double acting cylinder using the following conditions. Number one, the cylinder must extend at a minimum 500 psi. So there's a thing, sometimes the text says minimum and then certain amount of pressure. Sometimes it may say maximum. So when it says minimum, you know it's a sequence valve that they're talking about. So until you build up that pressure, the cylinder should stay put, should not do anything, extend or retract. When it says maximum, that means that is the highest value of pressure that the cylinder should be extended or retracted at. So they're talking about reducing the pressure to a maximum value. So remember, pay attention, whenever it is minimum pressure means they're referring to a sequence valve. Maximum pressure means they're referring to a reducing valve. This is super important to note. Now we're going to go through those conditions and see what are the conditions that we have to fulfill. The cylinder must extend at a minimum 500 psi. That means there must be a sequence valve. Then the retraction will take place normally over a bypass check valve. Because it's a double acting cylinder, now we're going to talk about a bypass, so that around the check valve we have to have a bypass so the retraction can happen. So that is something all circuit needs to do that use a double acting cylinder. Third condition is extension or retraction is controlled by a 4x2 foot pedal and spring. So that is the DCV they're talking about, and must be having a detailed HPU. So we begin by drawing the pump once again. So that's our pump. To make it hydraulic, we must blacken this triangle. We need a shaft to connect it to the motor. And then we need a filter. and everything begins from the reservoir. And then the pump needs a pressure relief valve, which is normally closed. Pilot line, the variable spring in place. Then there's a tank, that's our pressure relief valve. And then we'll have to have the DCV, which will be controlled by a foot pedal, 4x2 DCV. So there's 2 points of the DCV. I'm going to go ahead and draw the 2 positions for the DCV. And this looks like your foot pedal is pressed, and then the cylinder will extend, and foot pedal is depressed, the cylinder will retract. So we'll just have this kind of, because it's 4x2, there is no central position. It doesn't really matter whether you have the cross flow here or the through flow there. So you can just draw like this. And although it doesn't say, it's a good idea to actually put a hydraulic accumulator. See, it never said anything about that, but I'm going to put one anyway. No harm done. And there's the tank. Now, this one is operated by a foot pedal. You need to know how to draw certain symbols to get this circuit done properly. And now we have to draw this condition, which is the central condition to operate the double acting cylinder. So we're gonna have to draw a double acting cylinder here. There's our double acting cylinder. It has 2 ports. This one be connected to the DCV via a sequence valve. So we'll have to have a sequence valve right over here, normally closed. And it has a spring that pushes the spool to the right. It's a variable spring. Also, it has to have a external ring of its own. Those minute details you have to remember, otherwise you're not getting it right. So this is going from the DCV's inlet A. This is the B port. This is going to be the P. This is going to be the D port. Now, we have created the sequence valve. We need to pilot, and that's it. The sequence valve now is done. Then the retraction happens via a check valve bypass. So we'll also have to draw the check valve bypass. Pay attention to the direction of the check valve, because one way it should not allow any flow. So this is this way. It should not allow any flow. It should only allow fluid to come back. That's it. So pretty much this circuit is also done. What is left here for you to do is the labeling, double acting cylinder. This is going to be your sequence valve, external ring. This is the bypass. And this is your foot pedal, 4x2 foot pedal. This is hydropneumatic accumulator. That's the check valve. And this is the HPU, if you will, hydraulic power unit. And yeah, that's pretty much it. So we have fulfilled all these 4 different conditions and drew the circuit. So the circuits typically are rather simple. You just need to know the symbols very well, and you have to practice a little bit to get this done correctly.